Andromeda, also known as M31, is the most remote celestial object normally visible to the naked eye. The earliest known reference to it is by the Iranian astronomer Sufi, who called it the Little Cloud in his Book of Fixed Stars, 964 CE. Almost 1,000 years later, Edwin Hubble discovered that Andromeda is its own galaxy, 2.5 million light-years away. This 2025 Hubble Space Telescope coverage of Andromeda commemorates Edwin Hubble's discovery. Prior to that discovery, astronomers thought that the Milky Way was the entire universe. Andromeda, which is seen almost edge-on, is tilted by 77 degrees relative to Earth's view. It serves as a nearby laboratory for studying the astrophysics that control the formation and evolution of galaxies, such as star formation rate, stellar evolution, star chemical compositions, and dust production. Photographing Andromeda was a Herculean task because the galaxy is a much bigger target on the sky than the galaxies Hubble routinely observes. The full mosaic was carried out over 1,000 Hubble orbits, spanning more than a decade. Hubble's sharp imaging capabilities can resolve more than 200 million stars in the Andromeda galaxy, detecting only stars brighter than our Sun. But Andromeda's total population is estimated to be 1 trillion stars, with many less massive stars falling below Hubble's sensitivity limit. The northern half of Andromeda's disk has been successfully mapped in the Panchromatic Hubble Andromeda Treasury, PHAT for short. The program covered roughly 1/3 of M31's entire star-forming disk. This program was followed up by the Panchromatic Hubble Andromeda Southern Treasury, PHAST. It added images of approximately 100 million stars in the southern half of Andromeda. This sweeping view shows 1/3 of the Andromeda galaxy. It traces the galaxy from its central galactic bulge on the left, where stars are densely packed together, across lanes of stars and dust, to the sparser outskirts of its outer disk on the right. The galaxy's southern half appears fundamentally different from the north. Its features suggest that it has been more affected by the collision with M32, a compact dwarf elliptical satellite galaxy that's just 16,300 light-years from Andromeda's center. It is thought that the collision caused the formation of the giant southern stream of stars in Andromeda's halo, spanning approximately 490,000 light-years, extending outwards from the southern half of the disk. This would be consistent with the simultaneous burst of star formation seen in both M32 and M31. Here's a look at the star densities in the disk, the giant southern stream, and Andromeda's halo. In commemoration of Edwin Hubble's discovery of the Cepheid variable class star V1 in Andromeda 100 years ago, astronomers partnered with the American Association of Variable Star Observers to study the star. Based on their data, the Hubble Space Telescope was used to capture the star at its dimmest and brightest light. In addition to M32, Andromeda has 35 satellite galaxies. Here's an image from data collected by 1,000 Hubble orbits. Interestingly, half of the Andromeda satellite galaxies seem to be confined to a plane, all orbiting in the same direction. It is not yet understood why they appear this way. This work built a precise 3D mapping of all the dwarf galaxies and reconstructed how efficiently they formed new stars over nearly 14 billion years. Here's a view of a few of them.